Hello and welcome to BYJU'S Exam Prep. Welcome to another episode in our knowledge series where we shall be talking about ocean currents. Now, when you take a look at the oceanic waters, when you observe the water in the sea, largely it appears to be calm and undisturbed. But then the reality is something different. These oceanic waters and the waters which we find in the sea, they are also under consistent motion. Now this motion which we find in the oceanic waters is generally of two types. One motion is in a vertical direction, where the water can rise up, where the water can sink to the lower levels owing to the force of gravity, and that is dependent upon the density of water. The other motion which is observed in water is that of a horizontal motion, where water moves within the oceans in itself from one region to another. That is what we refer to as ocean currents. Now, when we talk about ocean currents, what are they? So we can say that ocean currents are basically a streamlined, predetermined flow of water within the oceans, whereby they have a definite direction. It is not as if they can randomly move anywhere and at any place. They have a predefined and predetermined direction. A volume of flow is associated with them, and they are like large rivers which are flowing within the oceanic bodies itself. That is what we refer to as ocean currents. If you observe the image on your screen right now, you would be observing a kind of a motion in a definite direction when it comes to the water movement. This is what we refer to as the ocean currents. Ocean currents, depending upon their strength, depending upon their properties, they can actually end up influencing not only the climatic conditions of a place, but also they can significantly influence the marine environment and marine ecosystem. Now, these ocean currents are not something which is new to us. For a long period of time, mankind has known about these ocean currents and has utilized these ocean currents in order to aid navigational as well as trading activities. But when we say the movement within the oceanic waters, why does this movement take place? How is this movement initiated? And why will it have a definite direction? In the sense that when you talk about certain ocean currents such as Gulf Stream, these are the ocean currents which end up transferring close to around 72 million gallons of water with each passing moment. So that tells you how much amount of water is actually moving. So then, what are the factors which lead to the causation and the formation of these ocean currents? If we take a look at the factors, we have a multitude of factors out there which not only end up initiating the movement, but they also end up ascribing a particular direction, a particular shape to the aforementioned movement. So let us analyze these factors one by one. The first factor is the factor of solar insolation. Now we know that the amount of insolation varies as we go across different latitude. The amount of solar insolation or the solar radiation which is present in the lower latitude is significantly greater. Now, because of greater amount of solar insolation, there is a substantial amount of heating as well. That heating leads to a kind of a thermal expansion of water. Now, what do we mean by thermal expansion? That refers to the expansion in any state of matter by the action of heat. So, as the water in the lower latitude is heated up quite substantially, that leads to a slight expansion within the water column itself. And as a result, we get a scenario whereby water in the region of the lower latitude gains a height as compared to the higher latitude, has a kind of a height gradient of around 8 centimeter. Even though this 8 centimeter might not seem to be a very large figure as of now, but considering the water bodies, this in itself is significant enough to initiate any kind of motion. So this height gradient, that is something which can initiate the movement of water from the lower latitude to the higher latitude. And this can be the initiation of an ocean current. But then you have to understand that this height gradient is created as a result of heating. Then you have the water in the lower latitude gaining a height. It can move to the higher latitude. But then what direction will it take? In which direction, in which path will it go? That is something which is determined by the movement of the winds. Which winds are we talking about here? So generally here we talk about the permanent wind system, the planetary or the permanent wind system. And which are the permanent winds? We have the three basic permanent winds in each hemisphere. We have the trades or the trade winds. Then we do have the westerlies in existence. And then we have the polar easterlies. Right? These are the different permanent winds that we have. And depending upon these wind movements, the water takes a certain direction. And wherever the water moves, owing to the direction of the winds, their movement can get further influenced. Either it can get counteracted or its movement can further speeden up as well. Then after that, you have the factor of Coriolis force. Now, Coriolis force is an apparent force which acts due to the rotation of Earth around its axis. Now, as Earth as a planet is rotating around its axis, any moving object in the northern hemisphere bends to its right, whereas any moving object in the southern hemisphere bends to its left. So as a consequence, as a result of that, when you have the oceanic waters moving in the northern hemisphere, they will always end up bending to their right. Always. So that is why in the northern hemisphere, the oceanic circulation that you come across is generally that of a clockwise circulation which is observed. While in the southern hemisphere, because of the same Coriolis effect, the winds will be turning to their left. And that is why in the southern hemisphere, the circulation that shall be achieved shall be an anti-clockwise circulation for that matter. And this is true for all the different oceanic waters other than the northern Indian Ocean. Northern Indian Ocean is a different matter altogether. Then we have the shape of the coastline. The shape of the coastline again influences the direction in which the water is going to move, the direction that the water's movement is going to take it to. For example, if you take a look at the eastern coast of North America, the water generally shapes along the coastline, and that is why the Gulf Stream, the direction that the Gulf Stream takes, is something which is quite apparent. Even when you take a look at the North Atlantic Drift or the northern portion of the Atlantic Ocean, there, depending upon wherever there are gaps within the coastline, wherever you have other water bodies coming in those areas, you have the currents moving in substantially. So that is what we get by the shape of the coastline. That also shapes or aids the direction of these ocean currents. And then we have the bottom relief features. This is a minor factor which influences the ocean current, but is a factor nonetheless. When we talk about the bottom relief, we are talking about relief features such as when we talk about, let's say, oceanic or rather mid-oceanic ridges. Okay, when we have mid-oceanic ridges. So these mid-oceanic ridges, they also significantly impact the movement and the direction taken by the water body. In many areas, for example, again, if we take the case of the northern Atlantic, we have the mid-Atlantic ridge in that region. And there, a part of the mid-Atlantic ridge, that is the Weichel-Thomson ridge, significantly aids in distracting the North Atlantic drift and thereby trifurcating it into many smaller parts. You have the Norwegian current, you have then the Erminger current, Rennell current, all of them, they get distributed in the northern Atlantic owing to the Weichsel-Thomson ridge. So bottom relief features, they are not active everywhere. So that is why their influence is not something which is prevalent everywhere. Their influence is concentrated in certain regions of the world itself. Okay, so these are the major factors which will influence the ocean current, its movement and the direction that it takes. Now these ocean currents, they can be further classified. They can be classified based on temperature. And based on temperature, they can be classified into cold current as well as they can be classified into a warm current. Now, what are these cold currents and warm currents? The name in itself is an ideal indicator that when we talk about a cold current, we are talking about a water temperature which is cold. But how cold or how warm? Do we have a predetermined temperature range that if the water temperature is less than 10 degrees C, we call it a cold current, otherwise it is a warm current? Absolutely not. Here, the condition which actually classifies this into cold or warm current is the comparison with the surrounding water temperature. This is basically in comparison with the surrounding water temperature. Now, what do we mean by the surrounding water temperature? What do we mean by the fact of surrounding water? So here, surrounding water generally ends up signifying water found across similar latitude. So for example, if we, let's say, take a water column or an ocean current having a temperature of 15 degrees Celsius, let us assume. Now, if that 15 degrees Celsius ocean current comes in the tropical waters, the water temperature in the tropical region is how much? It is generally in the range of 23 to 24 degrees Celsius, right? In the tropical areas. So as compared to the surrounding water, this current will be referred to as a cold current because the temperature of this current is lower. But suppose the same 15 degrees Celsius water gets bifurcated and moves to higher latitude around 60 degrees, 65 degree north. Now in this case, as it moves to the higher latitude, there the surrounding water temperature can be as low as 10 degrees Celsius. So in that case, in comparison, it will be a warm current. So it is always something which is achieved in the case of comparison. There is no absolute warm temperature and no absolute cold temperature. It is always something which we find out in comparison. Okay? Generally, as a general thumb rule, you can always understand this, that when you have water moving from higher latitude to lower latitude, that is what is classified as a cold current. Generally, water coming from higher latitude to lower latitude. Okay, that is referred to as a cold current. When you have water coming from lower latitude to higher latitude, from around the tropics to the poles, from lower latitude to the higher latitude, that is what we refer to as a warm current. So that can be a general understanding. Now then, we also have currents based upon the depth in which the water is moving. So all these influences that we saw, the factors which could influence the ocean current, that is the solar insolation, wind movement, etc., all these are active on the surface itself. You cannot have the impact of solar insolation at a depth of 3 kilometers. All these are restricted up till a depth of only around 300 to 400 meters. So based upon depth, we have a classification into two types. we have what we refer to as the surface currents, and then we have what is referred to as deep water currents. Now these surface currents, as the name tells you, that is something which is restricted up till a depth of around 400 meters from the sea level. Okay, beyond that you have the deep water currents in existence. These surface currents, they generally end up moving owing to the influence of the wind pattern, owing to the influence of solar heating, thermal expansion, etc. But then the deep water currents, they actually end up moving because of difference in density. And how is this difference in density achieved? That is a factor which we refer to as the thermohaline circulation. So this difference in density is achieved because of difference in temperature as well as difference in salinity level of the water. So that initiates a kind of a different circulation which we refer to as the thermohaline circulation. Majority of the water movement in the lower level, that is up till around 400 meters to the absolute ocean bottom, that is something where we observe the deep water currents. And surface water currents, they end up occupying only around 10% of the water motion across the ocean. Okay? So the ocean currents that we refer to, we generally refer to the surface currents in general. Now, this is a kind of a classification. This is a kind of a subdivision of the ocean currents based upon various different parameters. Now, after knowing this, if you take a quick glance, if you take a quick look at the ocean currents in various different oceans, here you will understand, and if you observe, there is a kind of a pattern associated with it. For example, you will actually observe that under the initiation, under the influence of the trade winds, the water which was expanded in the equatorial areas, in the tropical region, that water starts moving. As that water starts moving, because of the shape of the coastline and the Coriolis force, in the northern hemisphere it will bend to the right, and thereby you have warm waters going into the higher latitude and you have colder waters coming to the lower latitude. And overall you have a kind of a clockwise circulation which is achieved. Whereas in the southern hemisphere you have everything which bends to the left, and that is why you have a kind of an anti-clockwise circulation. Even in the southern hemisphere, observe, the warm Brazil current is a warm current as it brings water from the equatorial or the tropical region to the higher latitude. Falkland current is a cold current because it is bringing water from the higher latitude to the lower latitude. Similarly, the Venezuela current that you see is a cold current because it brings colder water from the lower latitude to the higher latitude. If you take a look in the northern hemisphere, you have the very strong Gulf Stream, which is a warm current, bringing water from lower latitude to higher latitude. And here you will come across the fact that you also have a cold current, that is the Labrador current. Now this Labrador current meets with the Gulf Stream, and this creates a condition which leads to the formation of ideal fishing grounds. Wherever you have the cold and the warm ocean currents, when they meet, that is very, very ideal for fishing activities. Okay? Now, the Gulf Stream moves further to the east and to the north, and you have the North Atlantic Drift, which, as we have talked about, it moves in any area, any direction where the coastline provides it with a certain kind of spacing. Okay, and this is in turn influenced not only by the wind movement but also by the more bottom relief in the form of mid-oceanic ridge which is present in the region. Something very similar in pattern is what is observed even in the Pacific. In the Pacific, if you will observe, again in the northern hemisphere, you have the movement of water initially from the east direction to the west direction. Why? Owing to the influence of the trade winds. The trade winds, they carry out that expanded water column which has got a height, they carry it out to the western direction. Eventually, in the northern hemisphere, they will bend to the right. In the southern hemisphere, they will bend to the left. And you have a complete circulation. Just like in the case of Atlantic, you had the Gulf Stream and the Labrador current meeting with each other. Here, you have the Kuroshio and the Oyashio currents which meet with each other. So this is also a very good fishing ground. Now, regarding the temperature factor, observe here. You have the North Pacific current, which then bifurcates into two. The same oceanic current, when it moves into the region around Alaska, it is termed as a warm Alaska current. Whereas the same waters, when they bring their waters to the lower latitude, because they are coming from higher latitude, we have a cold California current. Okay? Now, here it is very similar to what we observed in the Atlantic, because both Pacific and Atlantic, they are very similar in the sense of their profile. But if we take a look at the Indian Ocean, the northern Indian Ocean is where things get exciting and the things get a bit different. And that is because if you observe the northern part of Indian Ocean, it is surrounded by landmass. Rather than as compared to the Atlantic and Pacific where it is open in the north, here it is surrounded by landmass. So here the influence of wind movement is quite significant. And wind movement can actually reverse the direction of the ocean currents as well. So that is why during the months of June, July, or rather during the summer season, we can refer to it as the northern summer. During the northern summer, what is the direction of the wind? The wind pattern in general, you will observe during the monsoon season, the wind pattern in general is from southwest to northeast. So that is why observe the water movement also in this region to be that of around southwest to northeast. But then during the northern winters or during the time of the retreating and the northeast monsoon, the wind pattern completely reverses over the Indian subcontinent. And the wind pattern now becomes northeast to southwest. So accordingly, that will initiate a change in the direction of the ocean currents as well. And the wind is able to pick up the oceanic waters due to the force of resistance and thereby initiate a kind of a anti-clockwise circulation in the northern Indian Ocean. So northern Indian Ocean is the one where the direction of the movement can get completely reversed between the different seasons owing to the reversal of the direction of the wind movement. So that is what makes the currents in the Indian Ocean to be so very specific, to be so very different. Now, in the southern Indian Ocean, the matter is almost similar as you observe in the South Atlantic, in the South Pacific, because the profile of the ocean is again very similar. So here again you will have the South Equatorial current, then you have the Agulhas current and the Mozambique current, and eventually you have, just like you had the Venezuela current, the Peru current in both the other oceans, here also you have a cold ocean current, that is the West Australian current. Now all these oceanic currents, they bring about various different influences. Now, if you take a look at the influences, one of the factor is the climatological influence. The water, or rather when you have the winds coming over from warm ocean currents, these winds will always bring in rainfall. They also end up influencing the temperature in that region. For example, if you take the case or if you take the temperature of the northern Atlantic, the northern Atlantic is warmer as compared to its contemporary latitude because of the warm ocean current which comes into that region. Which is the warm ocean current? The North Atlantic drift. So that is the climatological impact. It can influence rainfall, it can bring rains, it can also bring about a rise or fall in temperature. Okay? Then we have the heat distribution. That is, how is heat distributed? So we know that the lower latitudes, they have a kind of a heat surplus, whereas the polar region, the higher latitudes, they have a kind of a heat deficit. So that transfer and distribution of heat, so that a balance is attained, so that an area does not become excessively cold and another area does not become unbearably hot, that transfer of heat is very essential to maintain the heat balance. And the ocean currents, because of their continuous movement, they bring about that heat balance. They bring warmer waters from lower latitude to the higher latitude and colder waters from higher latitude to the lower latitude. So that is done by these ocean currents. Then we have the formation of deserts. Now, this happens when you have a cold current near the coastline. Now, suppose there is a kind of a coastal landscape, let's say, and you have a cold current which moves thereby. Now, this cold current, what it will lead to is a condition of temperature inversion. Now, what is this condition of temperature inversion? This is a condition where the lower air temperature is colder and the upper air temperature is warmer. As a result of this, there is a kind of a stability attained, and because of the stability of the atmosphere, you have an absolute lack of rainfall. So wherever you have the cold currents in existence, especially across the western coastline of the continents, you will observe that there is a kind of a desert formation. For example, the Peru current or the Humboldt current in the region of Pacific, that is the southern Pacific on the western coastline of South America, that can be attributed to the dry conditions in the Atacama Desert. The West Australian current, which is again a cold current, creates dry condition in the Victorian Desert in Australia. Then you have the cold California current creating dry desert-like conditions in the Sierra Nevada Desert of North America. You have the cold Beniguela current also creating dry conditions in the region of the Kalahari Desert. So the desert formation is something which can be ascribed to the presence of these cold currents. But then these oceanic currents, they also have a significant role to play in circulation of nutrients, not only within the same ocean, but amongst the different oceans as well. And that is very, very essential for the survival as well as the thriving of the marine population. Wherever you have the cold and the warm ocean currents meet, that is what is leading to a boom in the population of the marine species and also serves as ideal fishing grounds. So these are the basic factors and the basic nuances that one needs to know about the ocean currents and the currents in circulation. Generally, you can expect a question regarding this in the mains examination, and also sometimes you have a couple of questions coming from there in the prelims examination. But then the basic facts that we have looked into, that is more than enough. So that will be all for the ocean currents, and now let us take few of the questions. So, first question will take by Ravi Raghuvanshi. Up to what depth from surface of the earth does oceanic water move as ocean current? So Ravi, we have the two different types. So for example, the surface current, that moves up till a depth of around 300 meters, 400 meters. But then you have the deep water circulation as well, which goes on to the further depth. Then one question by Maintlu, that is what is the relation between ocean currents and Coriolis force? So ocean currents, they actually bend owing to the Coriolis force. Coriolis force will be the force which will act on any moving object, be it a moving wind, be it a moving aircraft, be it a moving water body. So that is why even when the oceanic water moves, it bends to the right because of the Coriolis force in the northern hemisphere, and it will definitely bend to the left because of the Coriolis force in the southern hemisphere. Oceanic ridges are formed as a result of volcanic activities. and as a result of volcanic activities underwater, that leads to eruption of magma into lava, and that lava accumulates in the form of some kind of, it accumulates in the form of a height feature, a vertical height feature, and that is what we refer to as an oceanic ridge. This is where, when we look into the portion of plate tectonics, this is the region from where we experience the divergence of the crust and movement of the plates away from each other. Okay, this was a question by Surbhi Pandey. Then what is the, or rather, what are the effects of Coriolis force and permanent winds on India? This is again a question by Decian Maintlu. So that depends upon which season are you talking about. Coriolis force will act on all the wind movement. Okay, and permanent winds, these are the winds which bring monsoonal rainfall. These are the winds which bring winter rainfall in the form of western disturbances. So they have a lot of influences depending upon which part of the country you are talking about and which season you are talking about. Can rotation of Earth and season be the factors of ocean currents or not? Rotation of the Earth can definitely be a factor, and that is the factor which actually inculcates that kind of Coriolis force in action. That is because of the rotation of Earth. If that rotation of Earth would not have happened, you would not have observed the Coriolis force in action. And secondly, also the equatorial movement of waters, the counter-equatorial, some part of it is also ascribable to the rotation from west to east. However, majority of the counter-equatorial current, that is driven by the piling up of water. Okay. Then what are trade winds? Surya, trade winds, these are the permanent wind system. These are the winds which move from subtropical high pressure belt to the equatorial low pressure. That is what we refer to as the trade winds. Counter-equatorial current, these are the counter-equatorial currents basically, because when you have in the northern equator or the northern equatorial region, water moves from east to west, and in the southern equatorial region, again water movement is the same. That leads to accumulation of water on the western edge. Some part of it begins a kind of a flow back, and that flow back is what is referred to as the counter-equatorial current. Then why majorly deserts mostly located on the western side of many countries? That is what we have talked about, because of the cold current, the cold oceanic currents which are present. Those cold oceanic currents, Surbhi, they are present on the western part of the continents owing to the Coriolis force. Coriolis force means that water from the higher latitude, which is moving very close to the region of Antarctica, they will bend to the left and they will hit the western coastline of the continents. And when they will hit the western coastline, that will create desert-like condition. But Somalia doesn't have any cold oceanic current, still has desert. See, currents can lead to desert formation. Does not mean that all the deserts have their linkage with the oceanic currents in itself. Okay, you have to be very clear in this. Otherwise, how would Thar be a desert? Otherwise, how would Sahara be a desert? So desert formation is a different mechanism altogether. But then in certain cases, the currents can aid to that formation of a desert. Okay. Maximum salinity, why will it lead to maximum density? That is because in the per unit volume, the amount of materials will increase. So that is why the density will also increase. However, temperature is a more predominant factor in influencing density as compared to salinity. Okay. Then another question, what is solar insolation? Solar insolation is the amount of solar radiation or the solar energy received per unit area per unit time. That is what is referred to as solar insolation. So that is where I'll restrict the class for today. I'll restrict the session for today. I hope that this has helped somewhat in adding to your information and your knowledge for ocean currents. Join us again tomorrow, where we shall be talking about the heat budget of Earth. Thank you.